Hello everybody and welcome to the Enviresearch presentation on environmental risk assessment challenges under the BPR, focusing on product type 2, which are surface disinfectants, and product type 21, antifouling products. I'll give you a brief overview as to why we do environmental risk assessments, the approach under the BPR, how we do environmental risk assessments, and various complications and adaptations in order to complete them. Why conduct environmental risk assessments? So this is to ensure that there are no unacceptable risks to the environment by estimating the risk first and then mitigating against that risk if necessary. Let's look at environmental risk assessment challenges. Environmental risk assessments are becoming more complex and conservative than they have ever been before, so we need to adapt to keep on top of these changes. If we look at the top row of yellow circles here, there are lots of different regulations and guidance that we need to take into account in the first place. So that's, for example, guidance from ECHA or also from member states. In addition to that, there are new models, different inputs and outputs, as well as tiered risk assessment schemes, which sometimes use very simple models that actually approach quite complicated issues. This means that there must be changes in how environmental risk assessments are done, potentially changes in experiments using different model versions, as well as the endpoints and schemes. If we look at the row of blue circles here, you can see that the aspects of increased conservatism as well as lack of harmonisation can sometimes lead to uncertainty of outcomes. This leads to the requirement to have non-standard solutions when approaching environmental risk assessment challenges. As environmental specialists, this is Enviresearch's area of expertise. It should be noted that these points apply equally to plant protection products as well as the BPR. However, there are many ways in which the BPR is different. So how is the BPR different? BPR product types cover an immense range of diverse biocidal products. Within each of those there is variations with the application method, so it could be a spray, a wipe, a mop or a brush product. There'll be different types of packaging, whether it's direct use, whether you dilute it, are you mixing powders, are you mixing liquids. The use locations as well, so whether they're indoor or outdoor products, and also the user categories, which can vary from private use through to public or medical, professional use or also industrial settings. The plant protection product risk assessments are very prescriptive and well established and have been for some time. Within the BPR, there is greater variability in the approach to ensure that all of the emission pathways are considered. So, what are the challenges for environmental risk assessments? The biggest challenge is to make sure that you need to cover all active substances, their metabolites, and any environmental substances of concern. All of the co-formulants within the formulation are now included as part of an endocrine disruptor assessment as well. For environmental risk assessments, we must cover the in-use section of the product life cycle, which is the application and use, the service life, and sometimes the waste disposal as well. And within this, each product type has its own methodology. This slide is all about the key parameters. It's basically a who, what, when, where and why of the products that you're looking at. What is the active substance? How much of the product is used? When is the product used? How frequently is it used? How is the product applied? Who uses the product? And where do they use it? When we start doing an environmental risk assessment, we have to look at the relevant emissions. There are various environmental compartments to consider. For example, in the aquatic compartment, we have groundwater, surface water, sediment and water. There's also sometimes to consider a sewage treatment plant, as well as soil, including grassland and agricultural soil, and air. So each of these compartments may be analysed in great detail or completely disregarded depending on the product type and if it's relevant to the use. So how do we calculate emissions and exposure? Each BPR product type has a specific methodology for counting the emission to the environment, which is the exposure, called the Predicted Environmental Concentration, or PEC. There are emission scenario documents for each product type and product type specific amendments that we must consider for every application scenario that's relevant to the product that we're working on. Different models are recommended depending on the product type. So how do we calculate environmental risk? Each active substance and each environmental compartment has an agreed predicted no environmental effect concentration, or PNEC, that is established in the finalised competent authority report for that active substance. Depending on the availability of toxicity data, the assessment factor that is applied to that PNEC can vary. This changes the PNEC to a regulatory acceptable concentration, or RAC. So here we can see an easy calculation for working out the hazard quotient, or HQ, which is your PEC, your emission, divided by the RAC. An acceptable exposure is when your hazard quotient is less than 1. However, we must also bear in mind that some product types require that all active substances and environmental substances of concern hazard quotients are added together and still must be less than 1 for that environmental scenario. So, what happens when a hazard quotient is greater than 1? That's when we have to do an environmental risk assessment refinement. We would take the tiered approach. So tier 1 is the first look, very unrefined, conservative, simplest approach, and from that you move on to higher tiers, which very much depend on the product type, and often expert advice is needed. So how can we achieve an acceptable hazard quotient? We can look at the input parameters and understand where they came from and how they influence the results. This links back to the who, what, when, where and why slide. We can look at if the patterns for use are correct. Are they realistic, or are they far too simplistic, therefore making the risk assessment too conservative? Also, we can look at which refinement options can be applied. So this, for example, could be the degradation of an active substance over time. Enviresearch staff are actively involved in keeping up to date and setting standards as members of expert groups, advisory groups, and also assist in developing and refining higher tier mechanistic models for environmental risk assessments. This gives us insight into upcoming changes, adds weight to arguments, and we can use our plant protection knowledge and expertise and apply that to issues with biocidal risk assessments. This is the end of the general section, and we're now going to move on to specifics for product type 2, that's surface disinfectants. So let's look at product type 2. What is product type 2? Well, as I mentioned earlier, they're surface disinfectants and algicides that are not intended for direct application to humans or animals. So that means we're talking about surfaces such as walls and floors, equipment and furniture, disinfection of air, so that's through air conditioning systems, disinfection of water, for example in swimming pools and aquariums, and also product type 2 biocides can be incorporated into textiles and other materials, and this is for use in private, public, medical and industrial settings. So the ERAs can be challenging because of the intrinsic properties of the biocide and also the very varied uses within even this product type. So let's look at the relevant compartments for doing a product type 2 environmental risk assessment. The first step that we would do is check the emission scenario document for the details and the properties of the biocide, for example its mobility and persistence, to decide which one of these compartments in the image are relevant. We can also check previous competent authority reports to see if any precedents have been set. For product type 2, emissions are mainly wastewater to sewage treatment plants. For example, emptying a mop bucket into a sink, rinsing a clean cloth in a sink, and then that emission goes through to groundwater and surface water and then through to sediment. So let's have a look at the models that we'll use for product type 2 risk assessments. So we can estimate emissions and exposure to the environment using exposure models. For the tier 1, that's the most basic and simplistic overview, we can use UCs, and this is the most common tool for biocide environmental risk assessments Based on EU technical guidance documents, this Tier 1 is effectively a worst case, so it's all preset defaults that we can use. It's very simple and empirical, and it's actually a consumption-based approach, which is, for example, the application rate, frequency of use, and the method of use. This takes into account things like surface area and dilution. For example, do you use it once a month in a sink or every day on a floor? And there is a 2019 version of UCs which specifically supports biocide environmental risk assessment, which includes also now sewage treatment plant FATE as well. There are additional special use case models that we can use depending on if it's a relevant scenario for our product. For example, HardSpec is a HSE Tier 1 tool for plant protection products, but this can also be used for BPR algicides to calculate runoff from outdoor hard surface yards that have been treated. So let's look at some higher tier refinements for specific pathways that fail Tier 1 in product type 2. So we can look at the use of mitigation methods, for example, reducing accidental spillage by using non-spill bottles, avoiding losses down drains, which we can do using a defined cleanup protocol, and containing exposure, for example, sealing fumigated rooms, closing the room, sealing the doors, allowing dissipation time, etc. We can also focus on FATE modelling refinements. For example, refining the input parameters. Is the use pattern representative and realistic? We can refine the substance properties, for example, by replacing default parameters with study-based data or literature evidence instead of estimations. We can use higher tier models such as Focus to refine problem areas. These are mechanistic models that simulate the dynamic processes over time. And here, for example, we have Pearl, which is for groundwater leaching, and Swash for surface water inputs via drainage systems into ditches. Both of these are standard plant protection models that can also be used if it's a relevant pathway and UCs fails at Tier 1. We can also look at refinement of the endpoint derivation. This reduces the assessment factor used in calculating the PNEC with more data. So this is the end of the product type 2 section. So let's move on now to antifoulants, which are product type 21. So for those of you that aren't familiar with them, product type 21 are for antifiling products. These are underwater paints or treatments primarily used on vessels, but can also be used on aquaculture equipment and other marine structures. It's used to control the growth and settlement of fouling organisms, which can be from microbes through to higher forms of plant and animal species such as barnacles. There are various reasons for using antifoulants, primarily to reduce drag caused by barnacles and other large organisms, and also to minimise invasive species from vessels bringing these organisms into port. So there are three aspects to antifouling environmental risk assessments. First of all, we have the environment, which covers the hydrodynamics of water and also some sediment characteristics. The compound, which is the active substance, so we can include things like degradation in that, and also the emission, which is leach rate and use case, including the surface area of the vessel in question. So let's have a look at the scenarios involved for product type 21. The environmental scenarios cover service life, which are fresh and marine water based. For marinas, we have various scenarios that we need to include in the risk assessment if they're relevant. There is an OECD default marina, which must be carried out, but also you can in addition have relevant regional marinas such as the Mediterranean, Atlantic, two for the Baltic, and also freshwater marina if your product will be used in freshwater. Also, you can have a harbour and an open sea environmental risk assessment if these are relevant. For these scenarios, a combination may depend on the countries where registration is required, if the product is for marine or freshwater use, and also the vessel type. If we look at this list here, there are three main vessel types. There are leisure craft less than 24 metres, so that's a small yacht for amateur use. Leisure craft greater than 24 metres, which for example is a super yacht and you'd have professional use. The phrasing of amateur and professional use feels like it would impact more the human health risk assessment, but it does impact the environmental risk assessment as well. This is because professional only products have different formulations and compositions because the application techniques and personal protective equipment stipulations are different for a professional user. The third category here are commercial vessels, so this covers trade and business, naval and governmental vessels. So from the emissions aspect for product type 21, we need to look at the leach rate, which is the total cumulative amount of biocide released during the lifetime of a paint. That's in micrograms per centimetre squared. So we have a mass balance calculation method. There are two ways of doing this. The first is a CEPE method, which is the one that's listed in the emission scenario document, and CEPE are a trade association for the coating sector at an EU level, so that's an established method. However, there is a newer ISO method which is based on the same principle, so that's ISO 2010-10890. So the required information for both of these mass balance calculation methods are the substances involved, so that's the percent of your active substance, any co-biocides if there are any present, and any environmental substances of concern, for example zinc oxide. The scheme characteristics for your product, so your dry film thickness and the anticipated lifetime. Now the lifetimes for antifouling paints are much longer than, for example, product type 2 that we were looking at earlier, where you might have an antifouling product that's on a vessel for between 1 year and 5 years. We also need to look at the paint characteristics. That's the density, volume solids, and other aspects like that. So let's look at the modelling approaches that we can use for antifoulings. So first of all, we'll look at the Deltares Mampec model. Deltares were Delft Hydraulics, and in 1999 they introduced Mampec, which is a marine antifoulant model, to predict environmental concentrations. So since then there have been 7 new versions of Mampec improving the hydrodynamics, chemical fate modelling, to make sure that this is an accurate and representative model for the OECD scenarios that covers the harbour, the marina and the open sea, but you can also put in your own bespoke marinas if you need to, and also the regional marinas that I mentioned earlier, such as Mediterranean or Atlantic. It's an established and well-known model. It's easy to use, however it can be time consuming. The second approach is the ECHA HSE harmonised calculation sheets. These were introduced in 2017, and it's effectively an Excel spreadsheet and a series of spreadsheets as a calculation tool for the environmental releases. It covers the emission scenarios for those mentioned in Product Type 21's authorisation manual and the emission scenario document. So the harmonised calculation sheets only cover the OECD marina and regional marinas, so there's no harbour or open sea aspect, so no commercial use within that. They are easy to use, they are very quick. However, there are some calculation errors still remaining, and there's also no transparency of calculation. Currently, as it stands, applicants completing an environmental risk assessment for Product Type 21 can use either approach or both of them, and authorities will use both when they are assessing at the product authorisation stage. Okay, so let's move on to some refinements for Product Type 21. Refinements for environmental risk assessments may include things like refining your leach rate. For example, you can reduce your leach rate for moored vessels in a marina. Can you reduce the number of boats present? For example, is it a super yacht product where you physically can't fit in more than one or two into certain sizes of marinas? Let's have a look at the underwater surface area. For example, is it a propeller only product rather than a vessel hull product? We can perhaps apply application factor refinements and also review any background concentrations that may have had to have been included in the risk assessment. So we've come to the end of the presentation on environmental risk assessments. If anyone has any questions, please feel free to email me on the email address that's listed at the bottom of this slide. And also on the next slide there are a list of links and references that I've referred to throughout the presentation. If there are any queries about that, then again please just get in touch. Thank you very much for listening, and I look forward to hearing from you.